Hello, everyone. This presentation is for the final project of CS5800 algorithms. This is Sahiti.
Hi, this is Rohit Chandrakandambe.
Hello, this is
Hi,
Jyoti Pujara.
hi, this is Saugata Mukherjee.
The project that we've developed is called the sorting visualizer. So let's see what exactly a sorting visualizer is. Sorting algorithms play a fundamental role in computer science, and their efficiency significantly impacts the performance of a variety of applications. The goal of this project that we're trying to achieve is to develop a sorting visualizer that allows users to observe and understand various sorting algorithms in action. By creating a visual representation of these algorithms, we aim to enhance the understanding and appreciate their inner workings better. The visual representation will help us analyze the time required to sort different data sets and also the number of comparisons that are made by each of these sorting algorithms. In a real-world context, a sorting visualizer can be used by a data scientist to compare the performance of different sorting algorithms, a software engineer to debug a sorting algorithm that is not working as expected, or even a teacher to teach students about the different sorting algorithms via a visual representation. So essentially, what we're trying to solve here is how can sorting algorithms be better understood, compared, and optimized for various use cases through interactive and visual representations. So coming to the scope of the project, we are essentially focusing on 6 sorting algorithms here. And those include bubble sort, selection sort, insertion sort, merge sort, quick sort, and heap sort. And we are using HTML, JavaScript, and CSS to develop this project. And this is to ensure accessibility across various platforms and devices. And also, additionally, we will leverage the power of JavaScript for real-time visualization and user interaction. Coming to the key features. So the following key features will be included in our sorting visualizer. The first feature is algorithm selection. So the sorting algorithms that I just mentioned will be available to the users for visualizing the sorting process. A drop-down will be displayed from which users get to select the algorithm that they would like to visualize. The second feature is random data generation and custom file input. The application will allow users to generate random data sets of varying sizes to test and observe how each sorting algorithm performs with different inputs. And the user also is given the option to give manual input in the form of a text file. So this allows different forms of file input that can be generated through the user. The third key feature is visual representation. The sorting process is visually represented using animation, which enables the users to understand how the data elements are manipulated during sorting. The fourth feature is user-friendly interface. So the UI is designed to be intuitive and easy to navigate, making it accessible to users of all levels, including students, teachers, and developers. And finally, the fifth feature is number of comparisons. So the total number of comparisons made by the selected algorithm is prominently displayed at the top of the screen in the form of a pop-up where we display the exact number of comparisons that were taken by that particular algorithm. And this allows the users to see the direct impact of different approaches on the sorting process. So now we will be looking at the exact problem that we're trying to solve with the sorting visualizer.
Hi again, this is Rohit. I will be discussing the problems that a sorting visualizer solves. The first one is the complexity comprehension. The visualizer gives an idea of the time and space complexities for each algorithm for different inputs. This way we can understand what algorithm to use depending on the use case. The second is algorithm understanding. We display the step-by-step working of the algorithm. So comprehending the algorithms can be very difficult, especially when you're a beginner to the computer science course. And drawing from an example from my life, bubble sort was like one of the first algorithms I learned, and it took me quite some time to understand the working. At that time, I really wished for a tool that would help me understand and visualize the step-by-step iterations. And with this help, with this project, we are trying to solve that issue. Next, we have the algorithm comparison. There are like several situations where we need to know which algorithm would be the best depending on the input. With our project, we allow the users to compare the algorithms on the same input and also give out the number of comparisons. This way, we get to understand the best suited algorithm for our use case, and also it will be a very useful tool in developing hybrid sorting algorithms. Next is the learning and teaching aid. As I mentioned before, the project has a huge significance in helping students comprehend and understand the step-by-step working of the algorithm. The visualizer would help students understand the algorithms quicker and better, and also would aid the teachers as a really good teaching tool. Finally, as a debugging and optimization tool, the visualizer serves a tool for development of new algorithms or the visualization of complex algorithms in identifying the inefficiencies or ineffectiveness in an algorithm. Next. So this is our sorting visualizer UI. Jyotika would be continuing from here on.
Inner workings of the merge sort algorithm. This is one of the algorithms where we try to include different stages of an algorithm. Although all the other algorithms are explained clearly while presenting the application, as merge sort algorithm divides the entire array into sub-array until it cannot be divided further, and then sorts the elements into each of the sub-array and merges them to achieve the final stage, which is the final sorted state. The first, can you pass on to the next slide? The first stage of the merge sort algorithm is the initial unsorted state. As you can see from the picture here, the elements in the array are represented as bars, and the color red represents that the elements are not in the right place. By clicking the algorithm from the drop-down in the application starts the process of sorting the elements. So next stage is dividing into sub-arrays and sorting them. As you can clearly see, the sub-array is divided and has been sorted from the yellow bar first chunk. Similarly, the elements from the yellow bar recursively divide into sub-array and sort them accordingly. Going on to the next slide. The third stage is, the fourth stage is partially sorted states, wherein from the picture, you can clearly observe that the sub-arrays are divided and sorted in their own place, waiting to merge with their adjacent sub-arrays. This is another picture showing the partially sorted states, and going on to the next slide. Yeah. Passing on to the final stage, which is the final sorted state, where the elements are sorted and the color green represents the elements are in the right place of the array. Passing on to the next slide. As Sahiti mentioned, that the application would display the number of comparisons that the algorithm has made in order to sort the elements in the array in the form of an alert. As you can see, that an alert has been given showing the number of comparisons that the selected algorithm has been made. And now I'll pass on the presentation to Saugata, where he'll explain how the application actually works. Thank you.
Hi, I'm Saugato, and this is the project application that we have made. And I would like to quickly skim through a few of the algorithms, though Jyotika has talked about the merge sort algorithm in great detail. But about the other algorithms that we have, so I would quickly like to show the code. So one of the most common algorithms is the selection sort algorithm, which as you can see here, we are making use of two loops. And inside the two loops, the first loop is used to get the index of an element and store it in a min variable. And the second loop is used to get the actual min index by finding a value that is smaller than it. Then we swap the two elements, similar to what we do in other kinds of sorts, such as bubble sort. Next one is a bubble sort, wherein bubble sort, we start by considering the first two elements in the list, and then we compare the two elements, that is the first element with the second element. If the first element is greater than the second element, then we swap them. Otherwise, we leave them as it is. Next, we move on to the subsequent pairs and repeat the entire process. We similarly have the insertion sort logic in place here. And as you can see, the insertion sort, we get the elements one by one from index 1 to last. And then we compare with all the elements that are to the left of that particular index. And then we try to sort them in place. This algorithm too makes use of two loops in general. And yeah, there is another algorithm, that is the quick sort, which makes use of the partition logic. So in quick sort, the first step that we do is choosing a pivot element. So a pivot element mostly is the last element, and choosing the pivot element is a very important step in this algorithm because it determines the actual performance of the quick sort algorithm. Once the pivot is selected, the list is partitioned into two subarrays, like we can see here. And the goal is to move all the smaller elements to the left of the pivot and all the larger elements to the right of the pivot. This algorithm then recursively applies the sorting till we reach the base case and all the elements are sorted. So I would like to give a quick demo of all these sorting algorithms. So we have two ways of taking inputs in our file. So one is we can generate new arrays, which uses math.random in the background, and it generates random values for us. And subsequently, the bars are created for us. And the generation of the bars logic is done here in JavaScript, wherein we are actually getting the bars, and then we are trying to generate the length of each bar, and then we are displaying it to the UI. So yeah, so we can also manually adjust the size of the array. So in my case, I can keep it to let's say 31 elements, and then I select a particular sorting algorithm. So we can select bubble sort, and as you can see, there is a beautiful animation that goes in the background, and then all the elements are sorted. And basically all the bars are sorted based on the ascending order. Yeah. And at the end, we are also displaying the number of comparisons that were made for sorting. In this case, as there were a huge number of elements, so the total number of comparisons was 462. And at the end, we display everything in green, which means the sorting is complete. So this is one way that we have managed to take inputs. We have also supported one more way of taking input, and that is through custom file input. So here we have a file, and if I select this file, and if I hit on the submit button, then the file contents are read, and I can quickly show you what the file contents are, which in my case is these numbers 1672, and based on these numbers, we will generate bars of random height. And now if I hit on submit, so this first bar corresponds to 1, and the second bar corresponds to 6, and so on. And after doing this, if I select a particular sorting algorithm, in my case, I can select selection sort now. And if I do a selection sort, then all the bars would be arranged in ascending order. This also works in case if I select merge sort here. So in merge sort also, we are sorting all the bars, and then we are displaying the number of comparisons, which in this case was 16. So one more thing that we have done is we have adjusted the speed of sorting so that it becomes easier for the person to visualize at what speed the sorting is actually happening. So you can basically adjust the speed, and then based on that, the sorting algorithm would process or proceed further. A few things that we have managed, which are the error handling cases. So we have limited the file inputs to be of size from 1 to 100. So if I have a value that is more than 100, and if I try to enter that as file input, we should get a warning message. Yeah, like invalid number in the file. Please enter values from the range of 0 to 100. So we have tried managing these kinds of error handling situations as well in our application. So yeah, that's it. Thank you. I would like to hand it over to Sahiti for the final conclusion. Thanks.
Yeah, thank you, Sagata. So, in conclusion, with this project, we have successfully achieved our primary goal of enhancing the understanding and trying to appreciate the 6 fundamental sorting algorithms that we have chosen. And by creating a visual representation for each of these sorting algorithms, the users will be able to observe the algorithms in action, and they'll be able to comprehend how exactly these algorithms work. And this visualizer also allows users to witness the step-by-step execution of each of the algorithms uh, with data given in an unsorted state, and finally the data being sorted. Thank you.